everyone for joining. So yes, as Julie introduced me, myself is Kyle Gray, Energy Efficiency and Carbon Manager. I work within the Crown Estate in the group sustainability team, looking across our broader portfolios, but also focusing on the London portfolio. As Julie said, I'm going to take you through some of our net zero commitments, some of our workings on energy efficiency, and finally ending on carbon reporting and its importance. If there are any questions, feel free to put your hand up, put it in the comment, or I'll answer them at the end. Julie, you might need to flag to me if a hand goes up because I can't see it on my screen.
Of course I will.
Thank you very much. So in terms of our net zero carbon ambitions and our strategy, so at the end of 2020, we highlighted, or we suggested our first initial net zero strategy called Net Zero 2030. That came out in December 2020. That was made up of these three documents that you can see on the screen. These can be found on our website if you want to look in a bit more detail. But effectively, we had our response to the environmental emergency, and that was talking about, broadly speaking, about our 1.5 degree alignment, and speaking about the science of climate change, speaking about the biodiversity crisis and how we're going to work towards mitigating that. The second part was our net zero delivery strategy, and that looks at a number of metrics and methodologies that we were going to use to assess ourselves and ensure that we were on target to meet our net zero target. So that was looking in terms of, we need to develop a internal carbon pricing mechanism. It's looking at how we can use embodied carbon targets to drive performance, operational energy performance metrics such as neighbours for offices and other performance metrics to improve our operational energy performance, looking at the quantity of on-site renewables and off-site renewables to ensure that we're always increasing our renewable energy procurement where possible, and as well as, sorry, just on that green supply. So in terms of our percentage of high quality green tariffs, looking at our offsetting policy. So this is a really key and crucial part of our net zero targets. We want to make sure that we're offsetting in the right way and making sure we're following a demand reduction process first and not an offsetting process first. And finally, ensuring that we have adequate reporting and having a third party do assurance on that reporting, because we want to be really clear and transparent about what we're achieving and what we haven't achieved. And the final net zero reporting scope document is a well, I would call it a really interesting document, but it effectively goes through the greenhouse reporting processes in terms of scope 1, 2, and 3, and highlights where we think we're going to report compared to the industry leaders and the requirements. What you'll notice based on latest guidance and other real estate companies is they have been working towards what's called the SBTi net zero standard. That is currently something we are reviewing at this stage. However, we haven't assessed a date that we'll achieve that by, as we've been working through the broader requirements, because we're looking at in terms of our business, our scope in terms of our real estate portfolio, our rural portfolio, and our marine portfolio, means it's a particularly difficult task to ensure that we've come up with a robust and transparent target. So we're working on that, and we hope to be able to release more information on that next year. In terms of energy efficiency, it's really important that we have the right supply and we have the right efficiency strategy. So we've got a number of key metrics here below. So in terms of energy efficiency, it's really about optimizing our current assets, as well as replacing any particularly low efficiency units with higher performance alternatives, but not at the primary objective is not to reduce usability of the assets. Electrification of heat, moving away from fossil fuel boilers, such as gas boilers or oil boilers, to electric alternatives, such as air source heat pumps. This allows us to decarbonize on our specific assets, as well as taking advantage of any decarbonisation of the grid moving forward, something that we also help through our marine offshore wind turbine installations. Renewable energy generation on site, so where possible, maximising all available roof space for PV, but not at the cost of any biodiversity optioneering that we could do, as well as looking at any offsite opportunities as part of our rural portfolio that we could have larger PV arrays and potentially distribute that around our portfolio. And tenant engagement, this is probably the most crucial part. We supply energy to some of our spaces, and the way that the spaces are utilised, the temperature profiles, the systems, all come from our side, but effectively the majority of the energy consumption comes from small power, IT equipment, on-site catering, etc., etc. And that really comes from tenant engagement. So it's to reduce energy consumption there, it's got to be a really careful process that we need to follow to ensure that we are reducing energy consumption, but that's through optimization, not through reducing a service offering. And then finally, green tariff. So we do want to follow a reduction hierarchy first. However, at this point in time, we do have a priority to ensure that all tariffs that we are currently supplying are green tariffs. And then going forward, we want to speak to our tenants to ensure where possible we can help them move on to a green tariff as well. And then finally, in terms of our carbon reporting, so currently we report our GHG emissions, scope 1, 2, and 3 in our annual report. This is really crucial as it shows where we're spending our carbon or emitting our carbon and how we're performing on year to show that we're improving. These calculations are based on a mixture of recorded data and estimates. And that is something that we want to improve going forward to make sure we can better estimate our performance. But as you can see, scope 3 currently accounts for FY22. So that is a significant portion of our emissions, and scope 3 does include our tenant energy consumption, which does exceed our landlord energy, or scope 1 and 2, which is our procured energy consumption that we utilize. So tenant engagement is really important to us. And finally, this is an annual report, but we do hope to report on this more regularly and more accurately on a quarterly basis. So this will help us report on our performance and be really transparent about how we're meeting our targets, but as well help us to plan future interventions, ensure we understand that we're tackling the areas that are not only high carbon, but also will be most cost effective for us and our tenants. That's everything from my side, Julie. Were there any questions that arised?
Not as yet, but it's great that you've kept us on target there in terms of time.
No worries.
So that's brilliant. If we can hand over now to Danny, that would be marvellous. Thanks very much.
Thank you.
Thanks, Julie. Just bear with me when I share screen. My share screen button has just disappeared, of course. Here we are.
Okay, we can see that, Danny.
Okay, great, thank you. So this really forms part of a sort of bigger engineering vision that we have for the Crown Estate, really. When I first came into the Crown a few years ago, I did a sort of deep dive into the sort of performance of our assets and the performance of our teams that not only look after their assets, but design and construct and manage the process of construction. And came up with a diagram like this. All of these things came under sort of scrutiny, and we created a vision for all of these aspects of our journey through a building, from its design through to feedback from that building into the specification. And right at the bottom there, operational performance, it sits really closely. In fact, it sits right in what Kyle was just talking about. And really what we're talking about in operational performance, as Kyle quite rightly said, is squeezing the pips out of our existing assets. So really driving to optimize the performance of our assets. And to help us do that, we need the help of everybody involved, really. So particularly customers who spent a lot of the carbon that we see buildings being responsible for. So you'll see a number of times through this couple of pages that customers get quite a big mention, and smart technology gets quite a big mention. I mean, I think we've got a duty of care to create a building that's performing to its optimum, but to do that we need a partnership with our customers, and let them understand how difficult it is and how difficult they find it, and let us support them and let them support us. But really, what we find in this field is buildings that don't perform as they should. And what we do is we get a company to maintain our buildings. And if you look at what maintenance actually means, it basically means preserving condition or situation. And you know, we don't really want to be preserving a building that's not performing. We want to make it perform and optimize it. So we're kind of moving away from this word maintenance, largely because of a graph like this. And this is, generally speaking, the performance we find, not just at the Crown, across the industry, that we've got a building that we get handed over at practical completion. And one way or another, for one reason or another, it hasn't been commissioned particularly well. So it's not even operating at 100%. It's somewhere lower than that. And then we dawdle it along like that, and we do a lot of fit outs, and we don't really manage the fit out very well. So the performance drops again, because perhaps the fit out team didn't really understand what we were trying to do with the systems and how we operate the systems to make it more effective. And then slowly over time, we see this degrading of performance as people sort of just lose energy. And there's nobody in the team responsible for this performance. So nobody's monitoring this slow degradation of the performance. And then we'll get some breakdowns, and the performance will obviously fall again. And sometimes the repairs of them breakdowns don't increase the performance. They actually drop the performance, because again, you know, it has to be done quickly. It has to be done cost effectively. The people who are doing it maybe don't know how we've set that building up, what the control strategy is. So we find that we get a lot of buildings after a certain amount of years sitting in this kind of slow decline. And we've got to sort of yank them out of that slow decline to hit what Kyle's talking about there, and to you know, really squeeze the pips out of what we've done in the first place. It's a real shame that buildings do decline, because we put a lot of effort into the design of making them energy efficient. And this is really an SFG 20 maintenance regime, and that basically is a planned preventative maintenance schedule, where every 6 months you go and squirt some grease into a pump and you tick a box, and that's your maintenance done. Whether that pump needed grease or not, it's getting it every 6 months. Whether it made a positive difference or a negative difference, well, who knows really. So there's no real plan to make that pump perform, and there's no real plan or responsibility for the energy of that piece of kit. We changed that, and really, if I'm not mistaken, I think the change happens this week. So we've taken Integral and NG Bailey off the contract, and we're bringing on BGIS. BGIS have been shadowing for a couple of months now, but really on the 1st of December, excuse me, we really start to change from maintenance contract into a performance contract. And it's, yeah, this might not be very exciting to most, but it's quite exciting for some of us who look after buildings. So what we're trying to do now is say, well, actually a fit out, we monitor and manage the fit out correctly, and it shouldn't have any effect on the building performance. And then we, at PC of a building, at practical completion, it's the moment where we know the least about a building, and our knowledge should grow depending on how that building is managed, depending on how the building is used by the customers. We should learn more and more about the building and how to optimize its performance. So in many ways, the building's performance should increase slowly. As we sort of layer up technology, that will happen quicker and quicker. As we move away from this monthly or 6 monthly grease squirting into pumps and start to think about how we do that more cleverly, we really look at a more highly performant building. And the breakdown should happen less frequently and should happen you know, later in the process. And when they do happen, there's actually a chance there to increase the performance again by looking at new technology, looking at the system as a whole and how we can optimize the system from a design that might be several years old now. So that's the ambition that we've set at BGIS. And you can see from this graph that actually the performance difference could be quite marked. And, you know, we could start that by actually getting our buildings commissioned well, and we've put that into place now. So it's a sort of multi-angled approach, this. But ultimately, we can see there that the performance might be a huge jump. And really what that means in practical terms is looking after our equipment and our assets in a much more sophisticated way, and start to move away from squirting it with grease every 6 months, and squirt it with grease when it needs squirting with grease. and start to monitor vibration, temperature, electrical current use from that piece of kit. And when them things change, go and have a look at why it changed and what made it change, and address that change. Understand what is going wrong, what was going wrong, rather than just this kind of dumb approach of squirting grease into it every 6 months. And this really reduces pointless maintenance and leads to a better performing asset, better control, less downtime. And really, when you start to understand how these pieces of kit work, you can really start to put a plan in place for replacing that piece of kit before it breaks down and causes a sort of panic moment. So it's really about getting your asset fully under control. And the last slide here is showing how we've approached that. So the performance contract goes into a lot of detail, but basically what we've done is put some KPIs in BJS's contract that move away from how many times did you squirt that pump with grease and how many times did you tick that box, and starts to look at well, we want you to save 10% of energy on a building, something that they've never really been responsible for in many ways, and have kind of wanted to be responsible for this. So this has really put them in a different mind space, and they're really quite excited by this. And we've asked them to sort of record things better, repeat failures, repeat visits. If you're getting repeat failures and repeat visits to the same piece of kit, well, there's something wrong with that piece of kit that needs to be addressed. But you've got to be recording these things and monitoring these things to understand that that pump or whatever piece of kit it is needs some different attention. And I suppose finally, starting to really look after tenants more to help them understand what's going on when they have a problem and it leads to an intervention. Give them the details around it, give them a program of intervention, and give them some feedback and timescales, and really sort of bring them on the journey with us. And I think this is a real step change from where we've been in the past, which I think will really help and really lead to a high performance estate. And that's it from me, Julie. Thanks.
Thank you, Danny. We do have one question that's come in that we may want to take now, or we can give you some thinking time, which is how many engineers will be monitoring the performance on the portfolio, and will tenants receive a breakdown of their initial findings?
It's a tricky question. How many there is? I suspect Jacqueline on the call will be better placed to answer that, actually, but I think there's around 60 engineers, but working in shifts, so it's difficult to sort of say exactly at any one time. But yeah, it's a slightly different approach that takes a slightly different team of engineers. I don't know if you want to add to that, Jacqueline.
Hi everybody. Yes, yeah, Danny's right. This phase shift is going to take an army of engineers, but you don't need great boots on the ground if you're doing your job correctly. So it's a lot of training and a training in a mindset that's going to make the difference here. But we're right, there will be a 24/7 cover now, which we've never had before, and we will be doing a lot more training to make us more efficient. You know, the old adage, work smart, not hard. I think that will make the difference.
And I think the other thing that we were really keen on, we really pushed for, is a much more digital approach to managing the buildings. So BJA has come with a very mature digital offer that we, once we put that together, and it will take several months, if not longer, really, to get that working properly. But we do intend to open some of that up to customers, to answer the second part of that question. And just to answer that question a bit more thoroughly, the initial phase with BJIS is to do a full audit of all the plant, so we can start understanding the condition, what we've got, when we need to replace it, what level of maintenance that piece of kit needs, what attention we should give it, and we're going to create a full asset schedule of everything we have on the Central London estate, which will put us in a great place. It's a brilliant foundation to start that process. but we're very keen on interacting with customers and giving them a sort of overview of what we found and how we can help them and how, more importantly, they can help us.
That's brilliant. Thanks, Danny. We've got one other question. I don't want to delay the other speakers, but it's an interesting question, which is, are additional sensors and monitoring equipment easy to install, and will there be a disruption in doing so? And then there's another element, which is, who will pay for their purchase and installation?
Well, good question. In fact, much of the monitoring equipment is already in the assets themselves. We just don't use it. If you think about a chiller or a pump or an air handling unit or a fan coil unit, they all have sensors built in, and all of that information goes back to the BMS in the basement, and we don't really use it to its fullest. So a lot of the sensors are already there. We will be including some other sensors. We're looking at sensors around air quality, for example, particularly in our newer assets where we've got the ability to put air quality sensors externally, and that's really interesting for internal air quality, of course. And in terms of who will pay for any ones that are required, well, I guess generally speaking, somewhere between ourselves and BGIS actually, who are keen to invest some money to do their own sort of R&D and work on their digital offer. But if there's a sort of, and it goes back to that thing I'm talking about earlier about forming partnerships with tenants. We're quite happy to sort of form a partnership with a tenant who wants to trial things, and we're also quite happy to stump up some of that cost. So it's a bit of everybody, but essentially we've got most of them already, and the rest of them will be funded by either ourselves or BGIS at the moment.
That's brilliant. Thanks very much, Danny. We don't have any other questions. Well, we've got one more come in, but if that's okay, we'll move on to our third speaker, David Mead. If you could take over, please, David.
Yep. Hopefully you can now see the slide, utility trends and peak pricing. Yes, no. Good. Just so here I'm the utility manager at JLL, so just giving a little context over the last year and a half. It's been a fairly busy and eventful 12 months. Just to give some context for anyone who's out there doing the energy buying or working with those within their organization doing the energy buying, or those doing the energy buying for them, give you some idea of what's going on, some of the pressures and the drivers that are pushing the prices the way they are, and then maybe talk a little bit, or we'll talk a little bit about peak energy pricing and how that can be very effective for energy management and reducing costs as well. But first and foremost is this the energy pricing. This is a little graph from Carbon XGen, who advise on energy buying and a number of other utility aspects, and it's just to give an idea of where things have been going over the past few months, and people will be fully aware of it in the press, but just to get an idea of the scale of it, it's sometimes useful to have it graphically. Generally speaking, over the past 5-10 or so years, prices bobbed along between £50 a megawatt hour, 5 pence a unit, and about £80 per megawatt hour, about 8 pence a unit. If you got 5 pence, you're doing well. If you got 8 pence, it wasn't such a good day. That, by the way, is just the energy bit. There is also a charge from your local grid to deliver it, and from the national grid to balance the whole system. But what you've got here is there's that been sustained trend over the period of the ramp up to the conflict in Ukraine of the costs have been going up, and it peaked in August, and everyone remembers the headlines and how painful it was in August. And it's eased off a bit, but it's still, that new normal level is still very high. It is an appreciable step change difference from where we were 18 months, 2 years ago. So that's to sort of give some context of where we are all suppliers quoting the same market. You can't get a better deal by shopping around and going to another supplier. They are buying the energy in the same market. So it's very difficult to try and squeeze those extra few pounds out. There are strategies to do it, but it's difficult. The support level that the government announced, which runs until the end of March, if anyone is buying their own energy, you may have got some support of that. That's at £210 a megawatt hour, about 21p a unit. But as previously mentioned, you know, the old average used to be about 7p, so it is 3 times the previous levels that people were used to and the norms. So it's that level of step change that we're facing. I also have had lots of questions over the recent months about, well, how comes we're not exporting gas? We don't. Sorry, we're not exporting electricity. We don't buy electricity from overseas. How comes the prices have gone up so much? And it's because there is a link between gas and power in the UK. 50 to 60, maybe even a bit more of our electricity at any given time is generated by gas-fired power stations. So something that has an impact on the gas price feeds through fairly quickly into the electricity prices, and they take a view of, well, we think this gas price is going to be high for a long time, therefore your electricity price for next summer is going to be high because we think the gas price for next summer is still going to be high. So there is a linkage, given how much electricity is generated by gas on that. There is also a linkage between gas and peak demand to balance the system, and I'll come on to that on the next slide. As I mentioned, the suppliers have been the prices went very high in August, and thankfully they've eased off quite considerably, but they're still very high. Suppliers have started to quote again, but mostly for their existing customers to renew. They're very risk averse, suppliers at the moment, and that's because when you buy electricity, they book the energy for your demand in the market, and if you don't use it, they have to then sell it back to the market, and they get charged also by the network. So the cost of getting it wrong is very expensive. When it was bobbing along between 50, 60, 70, 80, if you got it wrong, it hurt, but it wasn't catastrophic. Now, if you book it in at, say, 54p a unit, but then your customer decides they're not going to use it and you have to sell it back, but at the point you sell it back, the market is only 270, you're going to take a hell of a hit on that difference. So that's why suppliers are being very cautious on this. So that's the context, and there's also then some peak pricing elements. Some bits of the bills that the supply gets charged are from the national grid for balancing the system, and particularly at peak times. So I'll come on to the next slide. Fingers crossed that there we go. So here's the next slide. It's a bit of a busy slide, apologies, but the first question is peak times and why it pays to be more efficient, particularly at peak times. And then I'll talk a little bit about security of supply, because again, that's been in the news quite a lot as well. So peak times, and I'm very simplistic, I'm assuming zero background knowledge on this. So the peak time is actually between 4 and 7 p.m. And the reason that is the peak time is that's because when the grid needs the most electricity. You can see that on this graph, if you follow on the little graphic, is the different supply types by generation. And you can see at the 1800, that's the peak demand, and that's the balance there. And the reason why it's highest at that point is because that is when commerce and the public sector and industry are all working, and the street lighting is coming online, and people are going home and starting to look after their kids and do the cooking, etc., etc. So in very simplistic terms, that's why peak demand is at that point. When the grid is trying to balance the demand, they've got all of their baseload usage, and a lot of that these days is from gas. But when they look to bring on the extra generation to cope with that extra demand, a lot of the time that will be gas. And when gas is very expensive, that makes it very expensive to run the grid, and those costs get filtered back into everybody's unit price. Not immediately, but they get filtered back in. So whatever the customer base can do to smooth out and reduce that peak demand between 4 and 7 will help reduce the cost of running the grid. It means you're not using the energy at the same time as well. And it helps you save your energy, and it helps the grid balance a bit better and keep their costs down. And it does also bring me back to the security of supply question, if I may briefly. There's been a lot in there in the news recently about those questions about what would happen. And the grid is quite rightly, they have a statutory requirement to keep the lights on and keep them as much as they can, and keep it running. What they've said is this is the plan. What will happen when it happens if we need to start turning power off to people? But to reassure you, there are very high conditions that will need to happen first, and we will get plenty of warning that these things are happening. There needs to be a cold snap happen, and that would push up the domestic heating demand. And then there's got to be no wind, so a lot of our electricity demand would, or sorry, our electricity generation rather, would drop away. It wouldn't be coming from wind power, and the grid would normally look to gas-fired power generation to make up the shortfall, which is fine if we've got lots of gas reserve. We can cope with lots of extra gas demand for keeping warm and lots of extra gas for running the power generation. The problem comes if we have low gas reserves and a protracted period with no wind and a protracted cold snap. As you can see, those three things would be quite publicly known, and you'd get plenty of warning. The final step would be the national grid would say those conditions have been met, and at 2 p.m. on a given day, they will say we will activate our plan tomorrow, and we will start cutting off power to given postcode areas. To find out which is your postcode area, it should be on your bill. If you don't get your bill, you can put it in your Power Cut 105, and those rotors will happen. So they will start cutting power to those areas. The chances of it happening are very, very slim because of the three conditions. But if they do happen, that's the rotor it will go in to share it out. So hopefully that's been useful. I know it's not necessarily the sort of the net zero messaging, but it's to give you an idea of the pricing and some of the time of day and the peak times. I'll hand back now. Julie, if you want to, and Michael.
Brilliant. Thank you, David. So we've heard about the Crown Estate strategy, we've heard about operations, and we've now heard about energy pricing and blackouts. And for me, the connecting point is efficiency on all of those areas. So I'd now like to hand over to Michael to give you an update on how occupiers can start to reduce energy consumption and feed into this bigger connecting conversation of efficiency. Thank you, Michael.
Thanks, Julie, and hi, everybody. Yes, if you just bear with me while I attempt to share my screen.
That's great. We can see that. Thank you.
Great. Thanks for confirming, Julie. Yes, so I've taken the opportunity to repurpose some existing slides that I have that were for a particular purpose, but I feel are going to be relevant. However, much will depend on your circumstances as occupiers and what you have control on. But obviously as well here we are now in the winter period, and there are particular concerns or issues to address regarding obviously the heating season that we're now in and the efficiency of related plant. And on the point regarding operations, so it was noted, I think, earlier, obviously with Danny and the intentions across the estate and looking to invest, make significant investments, opportunities to co-invest in CapEx projects, perhaps. I'm not going to look at that. I'm more focused on operational efficiency, what sort of activities, what sort of actions can be undertaken, low to no cost, to improve or reduce operational energy use. Now, much of this deck is a checklist, which I'll not delve into in too much detail, but I think it's happy to share, hopefully a resource that you can come back to. We have some points here about what we'll cover. Just quickly touch on the rules of thumb. So obviously just some key metrics to keep in mind about the potential benefit of actions around optimizing operational efficiency. So the first one, top left, looking at aligning the operation of your building to the actual need, to your occupation. Now, there's been a lot of change with a lot of occupiers in recent months, if not years, as a result of COVID, much more flexible working practices, in some cases drastically reduced utilization of space. So looking to operate buildings in a way that aligns with how they're being used, what needs there are, and what spaces are being used can really lead to really drastic energy savings, benefiting yourselves. Top right, another key metric, of course, the impact of adjusting your thermostat, really, the impact that 1 degree change can have upon your energy use, whether that's in heating or cooling. It's the heating primary concern at the moment. Pretty standard metrics, maybe you'll come across that before. Bottom left, bottom right, we can probably leave for the moment. In terms of preparing for winter, obviously we are where we are. Ideally, it's an activity that you'd come to during the autumn period to start making your preparations, assigning what responsibilities will be had by various stakeholders, what actions will be undertaken. And then you can come to the plant and control checks leading up to and into the winter period, which can then ideally be monitored, evaluated for their effectiveness, using the monitoring systems that you have in place or could potentially install as part of an ongoing efficiency program. Look to record those actions, see where improvements could be made next time around, or see indeed what actions or what activities need to be reversed or adapted for the cooling season as we go into the summer months, hopefully again soon. Okay, so the next few slides are looking at the particular checks. Now, okay, pass through this relatively quickly. I'm not sure who on the call, which occupiers will have control of at this level of their equipment. It obviously can vary, but I'm understanding that it's likely these are multi-tenanted properties. Please shout out if I'm wrong or if I'm correct even. And that it's central planned, managed by a third party or Crown Estate appointed facilities management firm. Now, a lot of these checks are standard practice, so I'm not saying that this is not being done. It's worthwhile running through similar checks through, and as occupiers looking to challenge your FM provider to ensure that good practice is being followed, or indeed allowing them to communicate, that indeed they are following good practices, that they can ideally be recognised for that as well. So certain checks on your heating or water plant, cooling, chilled water, distribution systems. So that plant that will be in your occupied spaces, the VAVs, for example, all relevant and important checks to run through, really. Control checks are, really important area, ensuring that that's really operating, or like a health check has been done. Good control processes are in place to ensure that all plant is coordinated, all sensors are calibrated, everything's working in an optimal fashion. Now there are, BMS systems are highly capable. There's obviously different forms of solution depending on the building that you occupy, different levels of complexity to the BMS system and the types of solutions that can be deployed. So these aren't one size fits all sort of checks that could be undertaken, but it's worth again running through them just to ensure that such measures can be undertaken, that they can be implemented, or indeed if they can't be implemented, understanding why, and potentially then is there an opportunity to improve the control systems on site? Is there an opportunity to invest in better control and monitoring? And lengthy control checks that could be run through. In terms of the actual workplaces, there are other simpler things to look to in terms of what may be in your immediate control. In terms of heating, the first one noted here is, are portable heaters being used by staff? It's not that common these days, perhaps, but I'm not saying don't use them, but ideally they shouldn't be used. So if they are being used, it's flagging a concern, flagging perhaps an issue that the centralized systems aren't working as effectively as they should be. So certainly something to flag to your FM teams, or something. It could be another aspect about looking to relocate people to where they are more comfortable. Obviously, some other sensible checks here, ensuring that windows are not open when the heating's on, ensuring that heating and air conditioning systems are not operating at the same time in the same place, ensuring that radiators are free from obstruction, and another check to do is in fact whether or not your air conditioning can be turned off in meeting rooms, for example, or areas. Can your workspace be zoned? Can certain areas be left idle or be left not as conditioned as occupied areas, given lower utilization rates, for example? Drafts can be a particular concern. Obviously, that's strongly related in the season to the indoor environmental quality, people's comfort, and your heat demand. So looking to ensure that drafts are addressed, identified, draft proofing put in place. Door seals are in place and in good condition. And again, just a general warning that employees should be aware that thermostats be turned down before opening any windows. Of course, where you have openable windows. Lighting, simple things to look to. Do you have LEDs in place? Is continuous lighting needed in all your occupied areas? If not, can appropriate sensors be put in place, or time switches, motion sensors, be light as well? And where you have manually switched lighting, are staff, colleagues aware of their responsibility to turn that off? In terms of equipment, all our IT systems have power saving settings. Are these being utilized? Have they been implemented across your IT? Can printers, have printers been set to automatically power down when not in use? And is there an opportunity regarding communal equipment? Is it being turned off at the end of the day? Can it be rationalized? So again, coming back to this utilization aspect, I've seen examples where occupiers have looked to switch off certain fridges where they've got multiple fridges in the floors, because in fact they only need one, given their current utilization levels. So that's something to look to. And the next, obviously, looking to the life cycle of your equipment. When's it due for replacement? Can it be replaced with higher energy rated equipment, so A+, which freezers, coffee machines, microwaves, etc. That was a relatively quick run through. I think I've stuck to time, or maybe we're a little over now, but I'm happy to take questions, Julie.
We haven't got any come through yet, Michael, but thank you for that. I think it's given me particularly a reminder that by just turning down the equipment by 1 degree, which can often be done on office floors by the occupiers themselves, that can generate a very efficient cost saving as well as kilowatt hour saving. So that's a great takeaway for me. We did have one question, which I think actually is going to be difficult to answer as a generic, and I'm not quite sure which one of you would like to answer it. It came up when Danny was talking, and this was: what interventions will be made by the Crown Estate JLL for customers who are responsible for repairs and maintenance in their lease? And for those customers, is the building owner or the leaseholder financially responsible for statutory environmental improvements to buildings? Now, my take on this is that it should be viewed almost building by building and occupier by occupier. But if anyone would like to add to that, then please do so.
Yeah, thanks, Julie. It's quite a complicated question, but
Yeah.
essentially we're not changing any leases. So if you're responsible for the maintenance of your kit, you're still responsible for the maintenance of your kit, of course. But generally speaking, and I'm talking about our directly managed assets here. Generally speaking, the plant is sort of split into two categories. Base build plant, which is the big kit in the basement and on the roof, and tenants plant, which is customer plant, which is basically in the customer space. A lot of the efficiency can come from the base build plant, and we're directly responsible for that plant. So a lot of the efficiencies and optimizations will be on us. If we find in our sort of investigations that, in fact, we've had this example only this week. We found when we were doing our own optimization through the BMS system that one of our customers was running one of their elements of plant for 24 hours a day, and it was quite a high energy use. And there was no obvious reason for this. So we got in contact with them. They kind of acknowledged that was not right, and subsequently together we've rectified that and put it on a time schedule that is much more representative of how it's used. So a good example of it's definitely their responsibility, but we found it, and we want to partner with them to sort of help them with their own energy use and their own journey towards net carbon zero. But essentially, a lot of the optimization is in our court in the base build, and if we go into the bigger interventions like replacing boilers for heat pumps, that's with us. But very much the maintenance and operation of the equipment on tenants' floors is certainly still the customer's responsibility. And this is where we want to partner with them and allow you to take our learnings and vice versa, so we can work together to optimize the building completely, really.
A brilliant answer, Danny. Thank you very much for taking that question. Much appreciated. We have run out of time. There are no other questions at present from our listeners. If there's anything that anyone would like to raise, then please do so by sending me an email, and I'll make sure that it's directed to the relevant panelists that's joined us today. So I'd like to say a really, really big thank you to Kyle and Danny, and to David and Michael. Thank you so much for joining us, everybody, and hopefully we'll catch up on the next session in the new year, where we'll be talking again about efficiency in our buildings and maybe sharing some of the progress that we've been able to make in the meantime, and share and keep everyone up to date. So thank you very much, everybody. Bye for now.
Thank you and goodbye.
Thank you very much, everyone.
Bye now. You're welcome.